Hello. In this episode, I will explain my DIY mist coolant constructions. And you can see here is the main body of the mist coolant. I use the normal spraying tube for it. It can be articulated. And this is the brass nozzle, and this is the pipe. Normally there are two chips coming into it. You can see one thicker, one thinner. Go to here, and there is a bottom bottle for the coolant, and also has two lines or two tube entering it, and also some switch controls to control the volume flow and control the on-off of the air. So before I detailedly explain the constructions, there are some criteria in understanding this cooling mist. The cooling tabs, that is the liquids that to be poured into this tank. There are commercial mist coolant solutions that are pre-mixed, and it usually more expensive than those that we need to dilute it with the water. So the pre-mixed solutions will be used in small amounts. So we have to this volume controls. And also the amount of the coolant used will also depends on the air pressure. There's the second one. This is the input compressed air pressures. So the higher the pressures, the flow rate out from the nozzle will be higher, and the coolant will be drained more quickly. This also has cooling and air flow rate. The fourth one is the air and coolant mixing location, and there's two locations that we can put them to be mixed. In my DIY one, is mixed at the tip of the nozzle. There are some simpler constructions that is mixing at a separate area here, a metal box here, and then the mixed coolant and the compressed air go from a tube, and this usually a long straight tube, and the moistureless air will be flow out from the opening of the tube. And the commercial ones like this, and I don't like this type of configurations because the straight metal tube, you cannot bend it to shoot the position of the workpiece. So I will choose this type of configuration, although it's a more complicated one. You can see I can articulate this in different angle. I don't know why it make like that in a long straight metal tube. Maybe if it was bended, there is chance for the moisture compressed air to be condensed at the bended curved location. But in this, the two mixtures, air and liquid, are mixed at the tip, so there is no this problem. And in these configurations, I use the input air pressures here at a low psi. I can do it with 10 to 20 psi. So for the solutions that I can use very little, I can control, and the usage will be at a lower levels. Now I open this tip and this is a brass nozzle body and a big hole here, and it's set inside, and this is the inner nozzle tube. And again, I can open it. You can see its detail. Actually, it consists of two parts, several parts. The front is a plastic pieces, and there is a very small hole drilled at this center, and there is a O-ring to seal. And I can here to explain a little bit. The air there is two small tiny hole here, and air will be come out from these two small hole, while the liquid will be come out from this front hole on the plastic pieces. Air come out here, liquid come out here, and they mix at the tip. And this body can be screwed so it can be moved front and backward. And when moving backward, this flat area will closer to the inner surface. At the end point, it will touch it, and no air will be come out, or the air is here, and no air will be come out from this large orifice. So I can use this to adjust the amount of airflow, and I can open it, and you can see this inside. Inside is this small thin tube, 3mm. You can see here. And where is the air come out? No. And solution go through inside this tube to this plastic head, while there is gap between this plastic tube and the inner wall of this brass, and air will be come through from this in between, and in this between, and come out from these two tiny hole on the brass nozzle pieces. And there is thread on here, I can screw fed on this intermediate pieces. This is made of aluminum, and this have the inner fed, screw fed, and the outer screw fed. The outer screw fed will mount this itself on the plastic parts, and also we will use this thread to assemble on this plastic body. And going to here, the entry area here, compressed air is going to this block and coming out to here and go through inside of this actuator's glue pieces. Although there is some air leakage in this gap here, but it's only very little. And also I use the lower air pressures, so this is not sufficient. So if you use high pressure, this is not a good method. In my this mixed cooling system, I use low pressure, so I can use just this juiced bottle to hold the pressurized liquid and air. Otherwise, if you need to buy a stronger bottle to hold them. Another liquid line go here and enter this area, and I need to seal here. And the liquid will be adjust its volume flow here. Use this plastic pieces. It's a simple pieces, and use screw. I machine this on CNC machines, and actually this is the main pieces. This part is just a holder, and there's this here and press against the flexible tube. This flexible PU tube, silicon tube here. The more advancing the screw, the less spaces inside, and so the lesser the volume flow through this volume of liquid flow through this tube. And this is coming from this bottle, and the bottle, this tube will small tube, this thin tube is liquid tube, and go down to the bottom of the bottle, and this airline just come here to pressurize the bottle to eject out the liquid. And here is the splitter. This airline come here and split and going through this switch. You can see here, turning switch is a cheaper pieces, and split into two compressed airline out. And this is a POM material, and you can see this figure and make it clear. This is the mixed coolant nozzle. This nozzle tip, liquid go through this inside thin tube, and after remove this body, outer body, you can see here I will operate it, and you can see liquid ejected from the hole of the plastic tip. Here is small hole on the front material. Compressor come out here. I can adjust the water level or solution level to reduce it. And this is the plastic pieces and very small nozzle hole here. This press fits on this brass tube here. There is flat here, so that this brass tube fixed on this metal pieces, and this metal piece fixed on this flexible plastic, blue color plastic tube. And this 1, 2, 3, 4 are all fixed at a fixed position. And here is an O-ring here, because liquid is going out here, air is coming here and pass through this small hole here. There is 2 small holes here on the brass inner tube, and this air will go forward and prevent it to going backward and leak out here. O-ring is put at here, and there is tiny gap here to let the compressed air going out. And you can see here is the liquid going out, and gas is spraying out here. So this liquid will be atomized here and become a mixed coolant, because the pressure, high pressure here, air pressure here will atomize the liquid here. And this gap, tiny gaps can be, the width of the opening of this gap can be adjusted by rotating this outer brass body, rotate it, then it will move backward and this gap will be less. And there is flat, inner flat here, engaged on these aluminum pieces. And going backward, here is the anchor. It's an aluminum block. There is a metal flat here. This flat is 1/8 pipe flat. It's a connector. It's metal connector. I use the aluminum or copper here. This orange part is the nozzle. It belongs to the nozzle, and I need to drill a side hole here and make a plug here, and also glue here to let the thin solution tube going inside. This inner tube is 3 mm in diameter. And air, compressed air will going from here and going upward here, and the compressed coolant will come here, and let us see the inner inlet. The inlet is a compressed air input. I use a low pressure 10 to 12 psi and passing through a lever tapped micro switch here, and it spreads into two routes. One is going to A, one is going to B. These two compressed air, A is here, you can see. B will go to the bottle here, and it will make the pressure accumulated here and press the solution go out from here and pass through a limit switch to adjust the volume, liquid volume flow, and it will go to C. There's this here. There's a whole conception of the mist coolant nozzle. Again, I can show you the detail. I use the instant AB glue to mix up and glue here for sealing. The epoxy glue AB tab. And I make this aluminum plate here as a platform and lock it on the lathe by these two metal C clamp. Improvement need to be made as further. The nozzle should move along with the settle so it can go together with the cutter. So later on I will make a magnetic base on this board here and put this whole assemblies on this settle here and use magnetic to stick on here, or I can make use of this screw hole here. And thank you for your watching.